Okay. There we go. Okay, so we want to go over the homework.
Yeah, that's a good
Part
idea.
2. Okay. So it's just part 2 we're going over, right?
Mm-hmm.
Yeah.
So number 7, what are the requirements for creating a 95% confidence T interval? So there are just 2. So it has to there has to be a random sample from the population, and then it needs to be normally distributed.
So how did you guys, let's see, I mean, does it say that it's normally distributed in the study there? Or did you put in like a Q plot to figure that out?
It doesn't say.
Because it's only, it has 15.
You're right. I didn't notice that.
Like I created a QQ plot on mine and it was pretty close to the line, but there was a little bit of curvies. And so I'm like, okay, I guess that looks pretty normal. But is that how you do it if you don't, like if you don't know, if you don't have a big enough sample size? I think that's the way they said to do it. Okay.
And that one, I mean, that one wasn't asking, I mean, I guess later on you need to know because you can't even do the rest of the problems if you don't know those 2 things, but at least for that specific one, it wasn't asking if it was normally distributed. It was just asking what the
what the requirements are.
But
I guess you have to know that anyways, right? For the problem. Okay.
And I figured since there were a bunch of other problems below it with that same data that it had to be usable.
Yeah.
Because otherwise.
But isn't 15 a large enough sample?
I don't think so, because it has to be over 30.
30.
Yeah.
So, yeah. All right. So let's go to number 8. Should I do that one?
Sure.
So with the data above, calculate the margin of error and create a 95% confidence interval. Okay, I don't want to read that whole thing. So I can't even remember how I did this now. So the margin of error, creating rounded upper and lower. Okay, I just got the upper and lower bound. And I just put it in the SPSS. Is that what you guys did?
Yeah.
And so does everybody know how to do that? So I went to SPSS, analyze, compare means, and then put one, and then sample t-test in. And then it gave me that that big box of stuff. And it just told us the upper and lower bound there. So
what were the numbers that you got for in doing it that way?
Let's see, what did I get? 41.8449 and 51.6218.
Okay, because in the textbook or in the wiki page it says, because there's two ways to get the upper and lower bounds, and it said like they won't be the same, so you have to use one of the ways. But I didn't really the wording wasn't clear, so I don't really know.
Yeah.
Did you read that too?
I was kind of confused by that, but let me pull that back up again because I was just looking at like 15.
The wording doesn't make any sense.
Yeah, but then there were like picture examples of it.
Yeah. Here, I'll find it. Oh, here it is. So a quick word of caution on something that many students get confused on. Using the explore function is the best way to calculate confidence intervals. Okay, so they say use explore. You may notice that the output for doing hypothesis test contains a category labeled 95% confidence intervals of the difference. This is the difference from the confidence interval of the mean given in the explore function, and we'll give you different values. Okay.
Yeah, so the little box below it, so the way we did that other problem was compare means, one sample t-test. So it's just saying don't use the lower and upper numbers in there and do it just the normal way. Explore.
Okay, that
Okay.
makes sense.
So
'Cause
there's a
they're-
couple ways to do that, huh?
Yeah.
Okay, let me see if I can put that in real quick. Maybe I'll figure it out. So analyze, descriptive statistics, explore,
Mhm.
and then you make sure it's 95%,
Yeah.
and then push OK. Okay, and then, all right, yeah, it gives you,
Is it the same numbers that you had?
yeah,
Oh, okay.
41.8449, is that right? And then 51.6218.
Yeah.
So that,
Okay.
it's
So those are the
on both.
same. So
So, okay. All right.
okay. So are we on 9 now?
Yeah.
I can do that. Now create 99% confidence interval to estimate the mean age of all the clients who built an investment property. Follow the same rounding rules as above. The t-score for 99%. Okay, blah, blah, blah. The mean, I think the mean's 46.73. Is that right? Oh, so we round to 1 decimal place, 46.7.
Are we on number 9?
Yeah.
So we're not doing like two numbers?
Number 9, I think, is the same as number 8, but you're doing 99 instead of 95.
Okay, you're right, because that's the answer I have, 39.9 and
Yeah.
15.5. But in the question it says, I guess I didn't read this question, it says estimate the mean. I don't know. Anyway, those are the upper and lower bound.
It's written, but
Yeah, it doesn't make sense because it does say estimate the mean.
Mm-hmm.
Doesn't say get the upper and lower bound, right? But that's what the answer was.
Yeah.
I'm
Number
like,
10,
okay.
we get the upper and lower bound anyway. So, yeah, that's confusing. The answer key does not match up with this.
Yeah, maybe they were wrong.
I think they are. Anyway,
Yeah, because
those are-
number 10, that's what we do. We do
yeah, it
the
has both of them.
95 and then 99. So let's walk through that 99. Like, how do you get that again? So you go to the same explore thing.
Yeah, here.
Descriptive
Let's see.
statistics. Explore.
Can't you do it by hand though too? It's just plugging it into the formulas, right?
I think so.
I don't know.
yeah, so it's basically the same, one of the same formulas from the last lesson, but
It's the there's like the student distribution formula and then the confidence intervals that just have T instead of.
Okay.
T and S instead of,
Okay, yeah, I found how to do that. So you just do it the same way and then just put in 99
put in
on the
99.
statistics. So yeah, that was 39.9484, 53.5183. Is that right?
Yep.
Okay, cool. Okay. Who's on this next one? 11.
I think it's me. Is it me again?
I haven't went, but
Kaylee.
Okay.
It says, how does the margin of error of the 95 confidence interval compare to the 99 interval? And then don't they get, I remember reading it in the book, but they get smaller. It's smaller for 95 than it is for 99.
Yep.
Okay, so 12 has a bunch of ones off of it. So for A, it says state the null and alternative hypothesis. So the null is equal to 47, and the alternative is not equal to 47. And then, sorry, compute the test statistic. So that one is negative 0.117.
Mm-hmm.
Yeah, I don't know. I got that one wrong, and I cannot figure out what I did wrong. I got like close. I got 0.118, and I'm not sure why I didn't get a
Did
negative.
you? Oh, I don't know why you didn't get a negative, but is that from computing it with the calculation, or was that from SPSS?
Just computing it. Yeah.
I got negative 0.118, and I was wondering why I was off. But my equation was 46.73 minus 47 over 8.83 over square root of 15. Is that what you had?
But is it so? It's t equals 46.73 minus 47? Because I thought it was the other way around. I put it in as 47 minus.
Oh yeah, it's 46.
46.73.
It's 46.73
Okay,
minus 47.
So the sample mean is first, right? The point estimate. So that was the point estimate. But then the mu.
Yeah.
I thought the mu was 47.
Yeah, the mu is 47. Wait, what's your question?
So how does the formula go? Does it go t equals x bar minus mu?
Minus mu, yep.
So I just don't get that, because I thought the x bar was 47. It's not.
So the x bar is the sample mean. Let's see. The x bar is the sample mean, which we computed in question 8, or yeah, problem 8. So the mean was 46.7, and that's when we took that slew of numbers and got the mean. I think we used SPSS to get it. And so that's the sample mean from the sample population that we have.
Okay.
If that makes more sense.
So I just mixed up my numbers. Okay. 46.
But yeah, I got negative 1.8118 instead of negative 0.117.
Okay.
But I'm sure SPSS is more accurate, so whatever that says.
Yeah, I don't know.
And that's what the answer said. Their answer.
Yeah.
Then the degrees of freedom for C, that one was 14.
Yeah, that's easy. At least the degrees of freedom is an easy version.
So you just check on SPSS for that one, right? And it tells you. Okay. That's what I did.
It's also just a sample minus 1, so 15 minus 1.
Oh, that's right. Okay.
Yeah.
So like if you can't use CPS.
Yeah.
All right. That
Yeah.
Okay.
That one's always just sample size minus 1.
Okay.
So sketching the t distribution. I just kind of
do that.
I don't know. I just watched him do it on the video.
Yeah.
I think he used the applet and.
So I thought you couldn't use the applet.
You can't, but he was just using it for like drawing purposes, just to kind of view what it would look like.
Okay. I haven't watched that part. That was the part I was like totally stuck on. The rest of the D through G, I didn't get those. Okay.
So then E was use your software to compute the p-value.
Mm-hmm.
So what did you guys get for that one?
So
I did not get that one.
Do you know how to find it with SPSS?
I have no idea.
I wish I could share my screen, but I have to use on my Mac. I have to use 2 different screens.
Okay. I mean, I can get my data up if you can just kind of walk through it, maybe.
Yeah, it's pretty easy. So you just go to Analyze, Compare Means, and then you're doing a 1 sample t-test.
Okay.
And then I think you put in the whatever percentage we're using. What is it?
95 or
95. So you put in 95%, and then you have to make sure you put in the test value at the very bottom. So we're testing the value of 47.
Okay, I did not do that. Okay, so if we put 47 in. Okay, there we go.
And so did you get it says one sample test and then it's that box of numbers.
Yeah.
So the SIG two-tailed,
Hmm.
that is the p-value.
Okay. So it's 0.909.
Yes, that's it.
Okay, cool. How did you know that's the p-value? Why don't I know that?
He told us. So, let's see.
It's
So
probably
this
in
is
my notes, but
it's a one sample test, so it's like the two ends. I don't know. If you think about the applet, the p-value is,
okay.
I don't know, that doesn't really make sense.
Well, I think I remember it now that you're saying that. Okay. And then if it's like only a one-tailed thing,
Yeah.
then you divide it
Then
in
you
half.
divide it. Yep.
Okay.
Yeah, I have no idea how to explain that. Sorry.
Okay. Yeah, I think I remember that though. So, alrighty.
Okay, so then F, state your decision. Do you reject the null hypothesis or fail to reject? So this one we would fail to reject because the p-value was greater,
What was our significance one?
0.05.
Okay.
And then present your conclusion in an English sentence. So that one, we have insufficient evidence to conclude that the mean age of this realtor's customers who are buying second homes is different than the national average.
Looks great.
Okay, cool.
Okay.
That really helps to talk to you gals about this because some of it I'm like, what did I do wrong? Okay. I get it now.
Does anyone have any questions about that or anything?
Not yet, but I guess we'll see.
I know.
Yeah.
We'll see with this quiz.
Yeah. If I can just get my numbers straight, like put the right numbers in, that would be
Yeah.
probably helpful.
I use my notes so much, so
Yeah.
that's nice.
Okay, I'm going to get up the quiz here. All right. Is everybody up?
Yeah. So. Okay, I'll read question 3. It says, in previous lessons, we had assumed the population standard deviation was known. In this lesson, we are making a different assumption about the population standard deviation. What has changed?
Mm-hmm.
So would that be A? We assume
Yeah. Unknown. Okay, so I can read the next one. For the next two questions, let the null and alternative hypothesis be u equals 8. And okay, how do you read that? The null is, the mean is equal to 8, and the alternative mean is greater than 8.
Mm-hmm.
Assume that population standard deviation is not known. Becker collects a sample size of n equals 9 and computes x bar equals 11 and s equals 6. So is sigma known? No.
What kind of question is that?
I'll take it.
That's two in a row that were the same thing.
Not known. It says right there. Okay.
So question 5, what is the value of t?
I guess this is where we need
I guess we can use the equation here.
Okay.
Okay, wait, how are we doing this again?
So we just use the formula for the test statistic t. So it's x bar minus mu over s divided by the square root of n.
Okay.
That one.
So
let's put in
So
that.
it's 11 minus
11.
8 Divided by.
over 6 square root of 9. Okay. Okay, did you guys get 1.5?
Yes, those are pretty easy numbers. No decimals or anything.
Yeah.
So 1.5.
Okay. Do you want me to do the next one?
Yes.
Yeah.
Okay. Using the following values, which were pulled from the data body temp for the next 5 questions, copy and paste them using your software, and it lists the numbers, and it says, what is X?
Shoot. So we have to have SPSS open for this.
I have it open.
I
can.
think so. So we
Mine-
just need to go to the file body temp. Okay, let me try to find that.
Wait, where are you getting that file so I don't have to copy the numbers?
I know what. Okay,
You can
Why
pull
don't
it
we
up.
just- why don't they just have a thing for us to click on?
Yeah, where is that?
This might take a while for me to find it. Okay.
It's like if you go to if you're in the textbook.
Where is it in the textbook?
Well, like, so any of the links in the textbook, I can't, and they have like a link. I don't know if they had it in this week's. Let me see.
Let's see.
Yeah, so if you go like to in the textbook, there's like
here we
the
go.
blue doors.
You're right. Body temp.
Yeah, and if you click on it, then it'll take you to another thing, and then if you
You're
click on
right.
it,
Okay. So which one are we using? Is it just called body temp?
But
Let's
the thing is, the body temp file has way more numbers than this.
Does it really? Please
So
tell me we don't have to enter in the numbers.
I don't think we can use that, right?
can you just copy and if you open it, maybe just copy and paste the numbers from there that are on here, or
Yeah,
can you copy and paste it from the quiz? Maybe that'd be easier than typing them all in.
Here, I'll try.
Or just open up a new one.
I can't. It won't even let me copy the numbers. Ugh, this stinks. Okay.
Do you want us to read them to you?
Actually, yeah, that'd be great.
Because they have to be in order, though. Are they in order?
No.
They're not.
No, they don't have to be.
from-
They don't have to be in order. That's only if you're
They
finding the
don't?
median. Yeah.
Okay.
Okay, good.
Yeah, I could read them to you.
Yeah. If someone reads them, that'd be great. I'm ready whenever
Okay.
you are.
You ready?
Yeah.
Okay, 98, 99.6, 97.8, 97.6, 98.7, 98.4, 98.9, 97.1, 99.2, 97.4, 99.1, 96.9, 98.8, 99.9, 96.8, 97, 98.7, 97.6, 98.7, 98.2.
Thank you. Okay. So that's 20 numbers. Hopefully there's 20 here. I'm sure there is. So we're looking for X bar. Crap, I don't even know how to find that. X bar is the sample mean.
Sample mean.
We're just looking for the sample mean. Okay, that's embarrassing. I'll find that real quick.
So you just do the
Explore.
analyze.
Yeah,
or
statistics, explore.
it'll give you the box with all the answers of numbers, right?
Yeah, so I got 98.2200.
220. I feel bad that we're all not like we don't all have this
Sorry.
up.
That's okay.
98.220.
Yeah, 98.22. So we're rounding to 3 decimal places. So do you keep that 0?
What's the number behind it?
0. So 98.220.
Yeah, it's
Sure.
probably either. So what is S then? So the S
This is
sample
the
standard
standard deviation.
deviation.
So the standard deviation is 0.92201.
So it just tells you that too, right?
Mhm.
Can you read
So
it one more time?
0.922. I think so. That's rounded to 3. So I think that's
Okay.
Yeah.
What is the t-score?
So now do we need to compute it? Wait, does it say it on there?
Let's see.
We can put it in the SPSS, right? Because if you do analyze and then compare means and then put one sample t-test, then it
Okay.
should give us that box.
You're right. Okay. Let's
So it
see.
should say t and then whatever that number is.
But we would need a test
Is that right?
value.
Yeah.
And I don't think the
So
test.
you put in 98.6 for that.
Okay. So 98.6. What we're testing.
Hmm.
Okay. So if we're testing 98.6, the t value is negative 1.843.
Negative 1.8.
843.
Yeah, negative 1.843.
Okay, so where did you put the test value into when you're on that?
Wait, what's your question? How did I get that value?
Yeah,
or-
because you guys were saying that you had to put a test value in.
Oh yeah, so it's at the very bottom. So you go to analyze, compare means, one sample test, and then it pulls up that box thing. And then at the very bottom, it just has a little box that says test value, and you have to make sure to
Okay.
put a number in there.
Okay. So I'm just gonna write that down so I know.
Okay.
Yeah, so I don't know if you know this part too, but you always put whatever number is used in the null hypothesis.
Okay.
You put that number in for the statistic.
Okay. Okay, then so what is the p-value? So that's that one where it says sig, right?
Yeah.
SIG
So
tell.
we got 0.081.
So is that going to be it, or do we need to split it in half?
Let's see. Is this? We have to split it because this is a one-tailed test.
It is. Why does it say that?
Because our alternative hypothesis, we want to know if it's less than 98.6. So we don't want to know if it's different. We just want to know if it's less than. So
Okay.
that's just one side.
So we do need to split it, huh?
Yeah. So that would be
0.041.
yes, 0.041.
Okay. Now it wouldn't be negative, would it?
I don't think so. Does it say negative? No, it doesn't say negative.
Okay.
No, because the p-value. Never mind. I don't know what the p-value is. I don't think it's negative though.
Okay.
So for this next one, since the level of significance is
What is it?
greater,
0.05. Okay.
So p-value is lower.
Smaller.
fail to reject.
Wait,
Wait.
so we reject it, right?
I think we reject it.
If the p is
Oh,
low,
yeah.
reject the null.
I read that wrong.
Okay. So reject the null. Okay. Okay, this one has a bunch of numbers too. This next one.
Oh no. Not enough.
Isabella, maybe we should, okay. It's from
Oh,
the
here we
Bio
go.
Baby
You
Boom.
baby boom. Let's see.
But I wonder if it's like gonna be more numbers than that.
Here, I'll check it out. I have it right here.
Okay.
Okay, so it is. Okay, it's 44 numbers, so I don't.
Yeah, that's not 44.
I can read them
Yeah.
off to you again.
Do you want me to do it this time? I have it up too, like just a blank one, because I want to try it. I want to make sure that I know what I'm
Well,
doing.
have her read it to both of us, and then you can do
Okay.
everything, and I'll
There
just
we go.
double check
Okay, yeah.
if
I
that
got
works.
Okay, you guys ready?
Yes.
Okay, 59, 14, 37, 62, 68, 2,
Wait. 62 and then 68. Okay, then what's after 68?
2,
Okay.
15, 9, 157, 27, 37, 2, 55, 86, 14, 4, 40, 36, 47, 9, 61.
Okay. I got 21
Me
sample
too.
size. Did you get that? Okay. Just to make sure. Okay, then so what does it say?
What are these numbers? They're so random.
I know,
Yeah.
they're not even close to each other.
Yeah, seriously. Oh, the average time between births.
Oh,
157 minutes? That stinks. Oh, wait. This is. Never mind. Okay. I was totally thinking of like
Between
twins,
births
the
at
minutes
hospital.
between having
Oh.
twins, but it's probably between different people.
That's hilarious. Okay, good.
All
Okay,
right.
so then what is the p-value? So we go here and we do the analyze. Would you do the explore or compare means thing?
I would do
Descriptive.
explore.
the p-value.
Wait, what is
We're
what
looking
is
for
this?
the p-value.
P-value.
that?
So maybe
Oh,
the
that's the
compare
SIG. You're right. You use the
sample
compare.
test thing.
Yeah.
Which one do you use?
Compare means for, and then you do the one sample t test because we're looking for the SIG, whatever.
No, we don't put in a test value, do we?
We do. So you always put in a test value.
Oh,
So it'll
okay.
be 40 this time.
Thanks.
40.
Yeah.
Wait, how do you know that? Does it say up there?
Yeah, so it's the null hypothesis. You use whatever numbers used for them.
Okay. Okay. Okay, so I got this box. Now, mine says the p-value, so the sig two-tailed 0.995.
That's what I
Did you
got.
get it?
Correct.
Okay, so we just got to determine if we need to split it in half or not. What does it say?
You wouldn't have to, right? Because it's two-tailed.
Yes. Yes.
Okay.
Okay, so what was the number again?
So, what was it? Let me check. 0.995. Okay.
And then what decision do you make? So the
that's
level of significance
bigger.
0.01.
So reject. No, fail to reject.
Yeah. Failed to reject because it's higher.
Yep.
Okay, and then the next question, you decide to try another alternative hypothesis. This time you use U is less than 40 and you keep the same level of significance. Did the p-value increase or decrease?
It would be
So
decrease.
decrease, right? Because so we would split that p-value in half, divide it by
Yes.
2.
Yeah, I
Okay.
didn't think of that.
But you would, for
So
number four,
the
still fail to reject the null, though.
um, I don't know, because what is it? Let's see.
Yeah,
So it's
so
half of 0.995. 0.995 divided by 2.
so 0.4.
0.497.
That's still,
Still
higher, right?
Yeah.
So fail to reject.
Fail to reject. Okay.
Okay, then 15, it says construct a 95% confidence interval for the true mean wait time between births at a hospital. They want to know what the lower limit is.
What is
So
the
do-
lower limit? Okay.
So that one you do,
It already is 95 confident, right? Because that's like a given.
Yeah. Do we keep all the same numbers though? Like the test value is still 40 and everything like that?
Yeah, I think
so
so.
this one you're going to do the other, so you'll do analyze, descriptive statistics, and then explore, and you'll look in that box.
Okay, let me try that.
Okay. So analyze, statistics, explore, and then you put the stats in for 95.
Yeah, so
oh,
the
it's already
stats
there.
95.
Okay. And then just, okay, let's see what it says. Okay, what are we looking for again?
Yeah.
So my lower bound says 23.4986.
Yeah, mine too.
Yours says, okay.
Oh, but
So-
round to 1 decimal place. So for
Okay,
23.5.
23.5 then.
And
And
then
then the upper bound is 56.5966, so 56.6. Okay, let me write that down. 23.
How come when you do, I don't understand how when you do both of those things, the upper bound and lower bound are different. I mean, I know we already read it, but
I know, like, why do you have to put in a whole different?
yeah. Anyway, that's just okay. Is there anything we want to go over? I'm super curious to see how we did on this test.
Yeah. Oh dear.
We got 100% other than, yeah.
Whoa, that was
You did?
that's
Wow.
impressive, guys.
Alrighty, you guys. I actually have to head to work right now, so
Yeah, I do too.
Okay.
Okay.
Good luck, guys. Bye.
Well, awesome. Thank you so much.
Thank you.
So helpful to meet with you guys.
All right, see you next Tuesday.
Okay, we'll see you later. Bye-bye.